Hi, my name is Silfvernagel, and today I'm going to be talking about affective computing. What is it and why should I care? But before we start the presentation, I'm just going to tell you a little bit of background facts about me. So my background is I have been working for 10 years with human-machine interfaces for process automation and robotics, and 10 years as a consultant. So my educational background is a master's degree in electrical engineering and also a master's degree in behavioral science. And I'm also interested in artificial intelligence and Internet of Things. So I am a Microsoft MVP in artificial intelligence, and I'm also part of the steering committee for two meetups, the Oslo AI meetup and the Norwegian.net user group meetup. But then affective computing, what is it? So a short explanation is that it's the human side of artificial intelligence. But if you want to have a little bit longer definition, we can say that this is the study and development of systems and devices that can recognize, interpret, process and simulate human effects. And that is emotions. So basically it is how can we use emotions in order to have a better interaction with machines, but also a better interaction from human to human. But before we start with this, we need to first understand a little bit more about emotions. So what is an emotion? So what we call emotions in daily life is actually three different things. So first we have from a psychological point of view. So first we can talk about emotions. They are fast automatic responses and they are temporary, and it's a reaction to a stressor. And emotions are also common to all people. Then second thing is what we call feelings. So with feelings, they are a cognitive awareness. So that means that we are aware of both the environment and the emotion. So this involves a thought process, and this is a long-lasting experience. And then we have affect and mood. So this is if we mix feelings and emotions together. And this is something complex. This could be long-lasting. So throughout the history, we've had different theories of emotions. So I'm going to take up the four most commonly used theories of emotions. So the first theory of emotion is from the 1880s. It's from two researchers called James and Lange. So what they said that we see something external and external stimuli, and this leads to physiological reaction. And the emotional reaction is dependent on the interpretation of this physiological reaction. So for example, if you see a grizzly bear, then you will have a physiological reaction, you will tremble, your heart will begin to race. And according to this researcher, will interpret this physiological response, and then you will conclude that you're frightened. But you're not trembling because you're frightened, you will feel frightened because you're trembling. But then in the 1920s there came a response to this theory by another set of researchers, Cannon and Bird. So what they said that we feel emotions and physiological response simultaneously. So what happens is that the thalamus will send a signal to the brain, and this will result in a physiological reaction. So you see a snake, and then you will feel both afraid and begin to tremble at the same time. But people, they experience the same physiological response to different types of emotions. So for example, sweating, heartbeat and respiration are similar for fear, excitement and anger. So the emotion and the physiological response are independent of each other. So the next theory is Schacter-Singer. So they have something called the two-factor theory of emotion, or the cognitive theory of emotion. This is from the 1960s. So here they focus on the interaction between two different factors, the physiological response and also the cognitive labeling of that response. So for example, if you're alone in the parking lot and then you're walking towards your car, and then there's a strange man that appears and approaches you fast. So what will happen is first you see that a strange man is appearing, and then you will have a physiological response. Your heart is start to race and you start to tremble. And then this rapid heart rate and trembling, these are caused by fear. So this is a cognitive labeling. And then you will deduce that you're frightened. And the last theory of emotion is from Lazarus from the 1980s. So he used something called the cognitive appraisal theory. So he said that first we do a primary cognitive appraisal. So we ask ourselves, what does this actually mean? So you can say that maybe this is not important, or this is good, or this is stressful. And then after that you do a secondary appraisal. So then you can either do positive appraisal, you can say that, oh, I can do this if I do my best, or if this fail, I will try another method. Or you can have a negative appraisal, I can't do this, I know I will fail, or I won't even try because my chances are too low. So an example of this is you see a bear in the woods, and then your primary appraisal is, this is stressful, but then your secondary appraisal could be, I can escape. So the emotional experience of fear and physiological response. So now the question is, how do we do to measure emotions? So in order to understand this, we have to go back in time to the late 1800s. So Charles Darwin, he wrote a book called The Expression of the Emotions in Man and Animals. In this book, he claimed that emotions are universal across the human species. And he also said that emotions have an evolutionary history. And around the same time, there was a French physician called Duchenne. So what he did, he wanted to study the mechanism of human facial expressions. So to do that, he used electrical probes. So he induced a small, weak electrical current in the faces of his patients, and that made the facial muscles react. So then he published a book called The Physiology of Movements in the 1860s. So in this book, he had pictures of 60 discrete emotions. But then if we fast forward another 100 years, there is an American psychologist called Paul Ekman. So he conducted studies regarding facial expressions and emotions. So he traveled to Papua New Guinea to study facial expressions. So he selected an isolated tribe, and then he found evidence that facial expressions and emotions are actually universal. And he also developed something we call the Atlas of Human Facial Expressions, which are still used today. And this is a standardized set for how we can study facial expressions. So we observe something called microexpressions in the face. And he also did further studies in various types of cultures, and he found out that there is actually a set of emotions that are universal across cultures. So there's some debate regarding how many of these universal emotions exist, but usually researchers say that there is between 7 and 9 universal emotions. So how can we do if we want to detect an emotion? So basically there are 3 main ways for emotion detection. Either you can do study facial and bodily expressions. So in this picture you see these different types of universal emotions. Or you can analyze the speech, you can analyze the tone, the intonation, the pulsation, and the rhythm. Or you can use physiology-based measures. You can measure the EEG or the heart rate, you can measure skin conductance or fMRI. So now we're going to be talking more about affective computing. So how did all of this start? So this started in the 1990s with a researcher at the MIT Media Lab called Rosalind Picard. She published a book called The Affective Computing, and by doing so she started a whole new field of research. So by now this research is a mature research field with its own IEEE proceedings and various international conferences and multiple research groups in various parts of the world. So what she said was that the machines should be able to sense the emotional state of the user, and by using cameras and microphones. And we should also be able to use speech recognition, gesture recognition, and image recognition. And we should be able to use machine learning in order to make sense out of all of this. But in the 1990s, a lot of these things were science fiction because of the state of the computer hardware at that time. But by now we can do most of these things that she claimed was science fiction. So this is due to some enabling technologies. So one of them is the sensor technology. So we have small sensors that can gather a lot of data and then can transmit it into big data lakes or where we can use big data tools to analyze this. We can also run machine learning algorithms in the cloud, and we as developers can use API and services to interact directly with this type of technologies. So now I'm going to give you some examples of these types of API and services that we can use. So the first is called the Microsoft Emotion API. So this is an example from the Cognitive Services suite, and with this service you can analyze pictures and you will get back an emotion profile, as we can see here. So woman in blue has a high probability of experiencing disgust, whereas the child in green has a high probability of experiencing surprise. So you can detect these types of emotions, as you can see in this slide. And most of the major cloud vendors have similar types of offerings. So for example, Amazon has something called the Amazon Recognition, and IBM has something called the Emotion Analysis API. So we're also going to study something called the IBM Watson Tone Analyzer. So the tone analyzer analyzes text, so it has text as input and outputs an emotional analysis of the text. So for example, in this text we can see that the main emotion in the text is anger, and you can see how strong the anger is based on the coloring, the red color in the text. So now I'm going to take up a couple of application scenarios. So first application scenario is within retail. So we can think about a store and that is equipped with different types of cameras that can register the facial expression of the customers. And by doing so, they can determine the emotions of the customers. And the staff can use this information to enhance the service and also give a much better experience to the customer. Then we have also within the medical field. So in the medical field, we could use physiology measures to determine the emotional state of the patient and also be able to reduce stress, among other things. And the medical team can be able to respond quicker to the needs of the patient. And in education, the teacher could use cameras to detect the emotions through the facial expressions of the students. So if the majority of students are feeling bored, then the teacher could change his method of teaching. And this could also be applied in an online setting where we can make use of web cameras in order to measure the emotions of the remote students. And then finally we have how it can be used in a social setting. So the problem here is that in large parts of the Western world we have a growing population of elderly people, but we don't have enough workers to aid them in their daily life. And one example of this is in Japan. So in Japan, they have done experiments using robots, so the robots can socialize with the elderly using both facial recognition, speech and tone evaluation, and physiology measures to adjust the behavior towards the elderly people. And now I'm going to take some example of what is actually in the front line. So we have a company called Affectiva. So they claim that they have the world's largest emotion database. So it contains 6 million faces across 87 countries. They offer an emotion SDK and an API that we as developers can use to integrate this technology in our own products. So examples of use cases are, for example, virtual assistant that can recognize the emotion of the user. You can also think of a personalized transportation experience, a self-driving car that can analyze the emotion of the passengers. So if they are in a good mood, it can adjust the music and also adjust the route. But if he recognizes that they are in a bad mood, they can take just the shortest path between two different points. And it can also be used in advertising to be able to understand if an advertise creates the right emotion at the right time. So this has been used in facial analysis and also in face and head tracking and speech analysis. And an example of use case here is that you can use this to detect if a person, if a driver gets drowsy, then you can issue an alert to wake him up so that he doesn't cause an accident. So they also have an app where we can try this out. So I'm going to show you what that looks like. So here you will see if I make different types of grimaces to simulate emotions, you can see what in green what the app recognizes as an emotion. And you can try this out yourself. I want to talk about Pepper. So Pepper is a robot developed by a Japanese company called SoftBank Robotics, and they are focusing on making robots that can adapt to humans. So Pepper was introduced in 2015, and it determines the emotions of the people around him by utilizing both voice and face recognition as well as body movements. So Pepper responds by changing the color of his eyes and the tone of his voice, and also the content that is displayed on his tablet. So he's been used in large bank in Japan, in Nestlé Nescafés, and also in the railway in various places in Japan. And also as of August 2018, he uses this Affective API for emotion recognition. Now we can ask ourselves, so what does the future looks like? Is this a threat for us or a hope? So then there has been various famous people that has made some statements. Like Elon Musk, he said that with artificial intelligence we are summoning the demon, that AI is our biggest existential threat. We also had Stephen Hawking, and he said that the development of full artificial intelligence could spell the end of the human race. And also back in the 1970s we had Marvin Minsky. He said that once the computers get controlled we might never get it back. We should survive at their sufferance. If we're lucky, they might keep us as pets. But we can also see here that maybe some people are overreacting. In the 70s, there was something called the symbol systems modeling. So some researchers said that this can solve everything for us, and this can potentially be dangerous. So we better alert the people. But they didn't need to do that because nothing really happened. And also in the 80s, we had different types of rule-based systems. So there were some researchers that said that Japan will dominate the world because they were using these rule-based systems. But that didn't happen either. So the question is, when will we have an AI that can actually surpass the human level of intelligence? So there's a researcher at MIT, Max Tegmark. He has made a research study among the researchers in this field, and then you can paint this diagram. So on one axis you ask about the time frame on the y-axis, and on the x-axis is if they believe is this a good thing if we will reach superhuman AI. So among the researchers there's virtually nobody that says that we will reach this point in just a few years. But then there's a lot more that says that we can reach this between a few decades from now up till 100 years from now. And then we can divide them into three different types of groups. We have one group that believes that this is definitely a bad thing, and we can call them the Luddites. And then we also have another group that says that this is definitely a good thing, and we call them the digital utopians. And then we have also a group which is in between that we call the beneficial AI movement. We also have some people that says that it will take a lot longer time. It will take maybe up to 300 years, or maybe we'll never reach this point. And we call this the techno-skeptics. So now I would like to talk a little bit about ethical AI. So when we talk about ethical AI, there is an experiment called the moral machine. So the moral machine was developed by researchers at the MIT Media Lab and was launched in 2014. So by now there has been millions of people in over 200 countries that has done this types of exercise. So what you do is you are asking yourself, what should a self-driving car do if it loses control and it sees a number of pedestrians crossing the street? So then it has to make some kind of a moral judgment here. Should it, for example, if it's humans and pets, should it value humans over the pets? If it's the passengers and the pedestrians, should it value the passengers over the pedestrians, and so on. So the question is here, can we actually expect a machine to make a moral judgment which is absolute? And is that fair to the machine? I mean, can we as humans, do we have some absolute moral? So what they found out in this study is quite interesting. So they found that it varies a lot between how the country is. If it's more of an individualistic culture, they are much more likely to spare the young people, whereas, for example, United Kingdom, whereas people which are more group cultures like Japan and China, they will spare the older people. And also it's a similar distinguish if you compare sparing more lives or fewer lives. So to the right you can see that this is an emphasis on sparing more lives, whereas to the left it's sparing less lives. You can also compare it sparing pedestrians over passengers. So if to the right you can see that these are sparing passengers and the other are sparing pedestrians. And then finally, I would like to talk a little bit about something called collective intelligence. So collective intelligence is nothing new. It has been known for a long time that a group of people have a higher chance of achieving great results than a set of individuals. So then there were some researchers, they wanted to find out, is there a single factor that can be found that we can call collective intelligence? And they found out in their studies that there is only a moderate correlation with the average individual intelligence. Instead, it was 3 different factors that were more highly correlated. So the first factor is something called the average social perceptiveness. So this is an exercise that you can do yourself. So what you're supposed to do is you will get an image where you can only see the eyes of a person, and then based on the eyes you should be able to judge what kind of feeling is that person experiencing. And then the second factor is the participation in group conversations, and here they found that it's very important and everyone needs to be able to have their say. There should be no dominant party in the group. And the third factor is the proportion of women in the group. The more women, the more intelligent groups, and this has to do with the social perceptiveness that I was just mentioning. So for us, this means that for us as individuals, that means that we need to be good at working together. We need to have good interpersonal skills. And also for computers, it's important that we need to be able to design these computers so that they can work well with people. And this is where affective computing comes into play. And I also have some reference for you, so I hope you found this was interesting and you want to learn more. So I have 3 books here that you can study a little bit more. So one is the book that I was mentioning, The Affective Computing by Rosalind Picard. And then we have a book called The Blueprint for Effective Computing by Klaus Scherer and Tanja Benzinger. And then finally we have a book called The Oxford Handbook of Effective Computing by Calvo, De Mello, Gratch and Kappas. So with that, I would like to thank you for your time, and you can reach me if you have any further questions on Twitter or on email. So thank you so much for your time.